All right, pull out your calculators, folks, because this is going to be one of my personal favorite kind of lessons. We're going to be looking at stuff with the calculator just to give us a graphical representation of some of these functions. Now, this is section 6.3, which we started in class. However, we need to do part C of each of these examples. We need to actually find the domains. So what we've already done is we've taken two functions, f of x and g of x, and we've combined them in different ways. In this case, in a and b, we added those two functions, and then b, we subtracted the two functions. However, today, I'm going to be looking at finding the domains. Now, finding the domains is tricky because it requires us to do a lot of thinking about what the functions are actually doing. First of all, we need to know the definition of domains. We need to understand domain as, I'll just say this, all the possible inputs. And we need to be able to think about all the possible inputs in a very broad sense. Luckily, we can get a sense of what's going on by looking at the graphs. So, that introduction aside, let's think about how we can find the domain first of f of x and g of x separately. Then we'll look at when we put these two functions together. I took the liberty of graphing f of x because I think if we can see the graph of f of x, we're going to understand what's going on. So there's 4x to the 1/2 in the calculator. Let's graph that and see what it's doing. Okay, so it's sort of making a curved line, kind of going up and to the right. Notice though, I don't know if you can see my cursor, but the graph just kind of stops. And in fact, the exact point that it stops at happens to be 0, 0, and we can see that if we look at the table. So take a look at the table. 0 and up, we have these nice values, okay? So we're going up, we're getting nice values. But let's see what happens if we go down. All of a sudden, when I'm going into negative x's, y is always error. Error, error, error. And that's because, graphically speaking, there is nothing on the graph. But really the reason why is because there's some sort of issue that happens when I input x's that are negative. And so we need to ask ourselves, what is going on with the negative inputs? So what is going on with the negative inputs? Well, remember, this 1/2 really means 4 times the square root of x. And what do we know about square roots? What can I not put into square roots? Oh, I can't put negatives into square roots. So in this case, my domain is everything from 0 up. And in fact, for f of x, I'm going to say the domain is non-negative numbers because anything 0 up is good, non-negative numbers. Because the only numbers I can't put in are negative, and the reason why I can't put in negatives is because it's a square root. Do you believe me that g of x is going to obey the same rules? Like, yeah, I'm multiplying by this -9 in front, but if you remember with quadratics, if I have a -9 in front, all that does is it makes the graph go down rather than up. But the point is that I still cannot be plugging in negative x's. The graph does not exist over there because I can't take the square root of a negative number. So I can't have a negative input. Okay, so the domain of f of x and g of x is both non-negative numbers. Now, when we look at the domain of a and b, we need to make sure to take into account the domain of f and g separately. We also need to take into account the domain of f and g together. So separately, I already know that the domain is going to be non-negative because if I can't plug non-negatives into f and g, then clearly when I add them together, I'm not going to be able to plug negatives into what they're adding. Like if I'm not allowed to plug in a negative here, why in the world would I be allowed to plug it in when I'm adding them together? So the domain is definitely non-negative. But we also need to look at this function and say to ourselves, is anything different going on here? And in this case, it's really not. I still have a function that is a square root function, right? This is -5 times the square root of x. So the same issue remains. I just need to make sure that I'm plugging in non-negatives. So as it turns out, the separately also happens to be exactly if we looked at the domain of just that function on its own, but it won't always be like that. And just because b is very similar, and because this video is dragging on, I'll say that for b, the domain is also non-negative because f and g are separately non-negative. Also, when I subtract them, I clearly get a square root function, so I need a non-negative domain. All right, let's next take a look at example number 2. Now, in example number 2, I have new f's and g's. I took the liberty of graphing 6x. Let's take a look at the graph. Look, it just makes a nice line. And if we look at the table, I can go down as low as I want. All of these x's are not producing an error in the y value. I can go as high as I want. I'm not seeing any errors show up on my x's. As it turns out, 6x, what could possibly go wrong here? I can plug in negatives, I can plug in positives. It's not like the square root where I have these weird restrictions. So the domain of f of x is all real numbers. And that's because there are no restrictions. I can plug anything into 6x. It's not like I'm taking the square root maybe of a negative number. It's simple. The domain, all real numbers. Next, let's take a look at the domain of g of x. So here I'm graphing x to the 3/4. Let's take a look at the graph. And look, it's doing something kind of similar to those square root functions before where it just stops. And if we look at the table, we can see that, okay, positive values are good, 0 is good, but as soon as I hit negatives, I'm getting error. And that's because remember what's going on here. Really, this is the 4th root of x cubed. And just like I can't take the square root of negative numbers, I'm also not allowed to take the 4th root of negative numbers. I'm not allowed, in fact, to take even roots of negative numbers. And the reason is, let's look at a more palatable example. I know the 4th root of 16, positive 16, is 2. But if I try to get the 4th root of negative 16, negative 2 doesn't work because negative 2 times itself 4 times ends up being positive 16. The pairs of negatives all cancel. So I'm not allowed to take the 4th root of a negative number. I'm not allowed to take the even root of any negative number. So just like the square root functions, this is going to be non-negatives for my domain. I can only input non-negatives for exactly the same reason that I can only input non-negatives in the square roots and any other even roots. So let's now take a look at the domains of a and b. Again, I have to look at them separately and I have to look at them together. So let's take a look at a, f of x times g of x. Okay, separately, I know that even though I can plug all real numbers into f of x, since I can only plug non-negatives into g of x, that means when I look at these domains together, I can only plug in non-negatives. Because even though I could plug in negatives here in f, I'm not allowed to plug in negatives here in g. We also need to look at what's happening with the function overall, but as with the square roots, it's just experiencing the same issue of being a 4th root, so I can't plug negatives in there. Now, the trickier example is b. Taking a look at b, obviously I know that I can only have non-negatives because g is already restricted to negatives, but there's an extra mini little restriction that we need to be really careful about. So take a look here. F of x is on top. G of x is on the bottom. We know the simplified result is 6x to the 1/4. But where did that come from? It came from me literally putting f of x, 6x, over g of x, x to the 3/4. Now, we need to look carefully at this function because is there anything that can go wrong here? Specifically, I'm thinking, what am I not allowed to divide by on the bottom of a fraction? And remember, you're not allowed to divide by 0. I'm not allowed to have 0 on the bottom of this fraction. And since I'm specifically defining my function as f of x over g of x, If I can plug in anything down here that gives me 0, if I can plug anything into g of x that gives me 0, then my function doesn't work. In this case, if I plug 0 in, so if I replace this x with a 0, this would be 0 to the 3/4 on the bottom, which is 0, and that would give me 6. I guess I should plug 0 in on the top. 6 times 0 over 0 to the 3/4, which is just 0. The point is, I'm dividing here by 0, which is bad. I'm not allowed to divide by 0. Terrible, terrible things happen to those who try to divide by 0. And so not only is this domain non-negatives, actually, I need to revise it. It's only positives. Non-negatives would include 0. So let me just write that. Non-negatives include 0, but as I saw from looking at the function separately, I cannot include 0. So I'm going to write only positives because this does not include 0, doesn't include 0. So this is a good example of we needed to look at the function separately, but we also need to look at what's going to happen when I put the functions together. F of x over g of x experiences the issue of I'm not allowed to divide by 0. So my domain is actually only positives. Pretty tricky stuff. Now, compositions are unfortunately the trickiest examples, but we'll get through them. First of all, let's define the domains separately. F of x, okay. This 4x to the negative 1, remember, really what that is 4 over x. What's going to be the issue here in my domain? Am I allowed to plug in negative numbers? Yeah, I could have something like 4 over negative 4. Like if I plugged negative 4 in for x, this is negative 1. But what am I not allowed to plug in? What am I not allowed to divide by? Well, 0. So for f of x, since I have that 0 on the bottom of my fraction, and I'm not allowed to divide by 0, the domain is going to be all real numbers except 0. So all real numbers but 0. Let's look at g of x. G of x is a simple linear function, just 5x minus 2. Basically, there's nothing going wrong here. I don't have a square root. I'm not dividing by 0. Those are my two classic cases of domain restrictions. Here, nothing is going on, so all real numbers. Okay, so let's look at a, b, and c together. So take a look here. I need to make sure for my inputs that g of x, I need to have that domain kind of be included, and then I need to have the whole thing be included. So for this one, we actually don't need to look at f of x separately. Up here, I looked at f of x and g of x separately and together because when I divided them, they were still kind of their own separate parts, f of x over g of x. Here, though, I'm only going to look at the domain of g of x because it's inputting into f of x. So I'm going to look at the domain of the thing I'm inputting, and then I'm going to look at the function as a whole. I do not need to look at f of x by itself because this function is now kind of like including g, if that makes sense. It's a little confusing to explain. So first of all, looking at just the input function. Well, its domain is all real numbers. So right now I'm just thinking everything is good so far. Now I can look at the function as a whole, which I know is 4 over 5x minus 2. Now, the only issue is going to come up if the bottom is equal to 0. What x would make the bottom equal to 0? Well, let's just solve that equation quickly. What x would make 5x minus 2, the bottom of my fraction, equals 0? That's 5x equals 2, x equals 2 over 5. So that's the bad x. That's the x that would make me divide by 0. And let me just illustrate that by plugging it in. If I go 4 over 5 times 2 over 5 minus 2, well, 5 times 2 over 5 is just 2, and 2 minus 2 is 0. So I have 4 over 0. Notice this 0 is the exact thing I couldn't plug into f. But now the thing that makes me get a 0 on the bottom is actually this 5 over 2. So the point is my domain, taking into account this all real numbers and this fact that x cannot equal 2/5, I'm going to say my domain is all real numbers except 2/5. All real numbers except 2/5. Because, yeah, okay. Let's take a look at B. Ooh, we're almost done. Okay, like I said, we need to look at the domain of the input function. We know that that's all real numbers but 0. So I'm just looking at F, all real numbers except 0, because I'm looking at the domain of the input function. Now I need to look at the domain of the function as a whole. Looking at this, I still have the issue. I can't plug in 0 here. That would make me divide by 0, but it looks like the only issue. So my domain here is all real numbers but 0. I looked at f of x to find that, and then looking at the function as a whole, I have the same issue. Finally, this C is a deceptive one, because if we look at the function as a whole, does it look like there's anything wrong with x? No, I could put anything in for x. There's no issues there. But this is why we need to also look at my input function. I'm not allowed to put 0 into my f of x. So if I'm not allowed to put 0 in here, I wouldn't be able to put 0 into the function as a whole. So here, the domain is, because f of x's domain is this, all real numbers except 0. All real numbers except 0. And it's because even though it looks like I can plug 0 in here, I would not be allowed to plug 0 just into f of x. Whew, that was a long video. The longest one yet. I'm setting all sorts of new records this year. Anyway, domains, they're super tricky. Remember, domains is what are all the possible inputs. We discussed a couple different rules for thinking about it when we're dealing with functions as a whole. So hopefully this gives you a good introduction, and of course, we'll practice a lot in class. See ya.